Hello everyone, welcome to the channel Unbox Your Mind. So we are doing the second video on this basic component series, that is a capacitor. If you are new to this video, haven't seen the previous one, so please also view the previous one because we are continuing the previous resistor with the capacitor with the simulation. Yes, we'll get started. So in this video we'll be seeing about the capacitor, what is it and how it works and where it is using, and application, testing and simulation. So don't skip the video until last. So we have at last we have a very interesting simulation part that is very interesting. So one thing before starting the video, as such capacitor is concerned, risk of electric shock, that is never touch the lids of the charged capacitor, that you don't know whether the capacitor is charged or not, so never touch the lids of the capacitor with your bare hands. Okay, well, the definition of a capacitor is a device that stores electrical energy in an electric field. So everyone will know the definition of the capacitor, but we'll try to understand what is a capacitor is. So basically a capacitor is a tank, water tank, a storage tank. So as you can see here, the water is flowing through the pipe. This is the incoming valve and this is the outgoing valve. So we want uninterrupted supply in the outlet. So we are having a small storage tank. So as you can see the second image, even when there is a small interruption in the inlet, we'll get some continuous supply in the outlet. So that's the advantages of the capacitor. Well, we all have a rooftop tank. So what's the advantages of the rooftop tank? Mainly it is we want uninterrupted water supply, right? So as like that, in circuits also we want in some cases we want uninterrupted supplies. For that we will be using capacitors. This is a basic analogy, and yeah, last video also we have seen the water analogy. So according to that, the storing the tank is similar to charging cycle of a capacitor, and draining the tank is similar to the discharging cycle of a capacitor. So here comes the working of a capacitor. So the working of the capacitor is actually a beautiful concept. Like we'll consider two parallel plates, simply parallel plates. In any materials, all the atoms will be in neutral state, but if we connect any potential across the plates, then the electron will start flowing from negative potential to the negative plate. So as the electron will move, accumulate in the second plate, and of course same charge will repel each other. So the accumulation of electron in second plate makes to repel the electron already there in first plate, so that the electron in first plate will come to its will gradually move towards the positive end. So here's a question: will electron pass through the plate? That is, here the circuit is not completed, right? Then how the electron will pass through the circuit? But if see here, there is a gap between, here it may be a dielectric or air, but there is no conduction between the plates, so there is no movement of electron between the plates. So then how electrons will get path to circulate in this circuit? So that's the most interesting thing in capacitors. So if not, how the circuit is completed? That's the most beautiful concept of the capacitor. We'll see. So as soon as the electrons started to accumulate here in the second plate, first plate, in the electrons present in the first plate will repelled by the second plate electrons and started to move in this direction. So this is what happening. There is no interaction between the second plate and first plate, but by the movement of electrons, but there is electric field formed. So due to the repulsion of electrons in second plate, the electrons present in first plate will move gradually towards the positive end. So this is how the circuit is completed, and continuously the electrons will accumulate more and more, and the electrons will leave equal amount in first plate, makes the first plate net positive charge. So another question, how long this can happen? So until the voltage across the capacitor that is equal to the battery. So the electrons will accumulate continuously until the voltage between the capacitor plates and the battery is equal. So after that, what happens? So after we disconnect the battery voltage source, after we disconnect the battery, even though there is we disconnected, but the charges present on the two plates will be there because of the electric field formed by the positive then and the negative things. So that's what the definition says. It stores electrical energy, that is positive and negative, by electric field. So as the electrons will be highly energized, that is attracted to positive protons in the other plates, but cannot have a path to neutralize itself. So it will remain same until we create a path. So if we connect a wire externally, so the electrons will search path to positive plate. So if we connect this wire, it will suddenly all of a sudden it will go to the positive plate, and it tries its to neutralize, and after that the electron will be neutralized. The two plates will be neutralized and it will be still. So in here the current direction will be like this. This is not conventional current direction, this is the electron flow direction. And yeah, here is the working, like after charged, if instead of a wire, if we connect a bulb or any load, the electron will get a path and move in this direction. So ultimately we have current through the bulb, so the bulb will glow. So after some time the electrons will started to move, and the number of electrons present in the second plate will gradually reduces, and the brightness of the bulb will be reduced. So after some point of time, both the plates will be neutralized and the bulb will not be glowing. So that's it. And this is the graph of the charging cycle and discharging cycle. So as you can see, the first graph, the capacitor will be continuously exponentially charging itself, and in second graph it will be continuously discharging until a point. So these are the various types of capacitors. We have non-polarized capacitors, polarized capacitors. Under that we have ceramic, electrolytic, and you will be seeing everything in the upcoming sessions. So and testing of a capacitor. Here's how testing of a capacitor. First two things you need to see in a capacitor. That is, one is the voltage rating and the capacitance. So it will be mentioned in the capacitor itself, that is 25 volts and 330 microfarad this capacitor. So we have to note two things, one is voltage rating and capacitance. For testing a capacitor, we need to check the voltage rating. So we need to move the turn the multimeter into the voltmeter, and we have to touch the two leads with the positive and negative one. If it is a polarized, then positive lead should be connected to the positive end, that is a longer lead. If it is unpolarized, then it's not a matter. So you will be getting in voltmeter you will be getting 25 volts. If approximately that is equal, then your capacitor is working, and with the capacitance mode you can also approximately test the capacitance. So now it's an interesting part, that the simulation part. we can simulate and see how a capacitor works. So I've picked the current source, that is 1 milliamps current source, and I have picked a single pole double throw switch so that we can make two circuits, and we have a capacitor, 1 microfarad capacitor. We can also change the values, and we have resistor. So yes, we now we can connect, and of course we have ground here. Yeah, let's simulate. Okay, so as soon as the switch is closed, the the capacitor is continuously charging. You can see here in the graph, that is the charging cycle of the capacitor. It will reach up to a certain value where the current is fully charged, where the capacitor is fully charged. After that, if we change the switch, like if we change the switch, you can see the discharging cycle, it will reduce suddenly. So we can also observe the discharging cycle with the help of a LED lamp. So let me pick a lamp. Yeah. So let this be connected. Okay. So now the capacitor is charging. So let it be charged up to the maximum value of the capacitor. You can see observe the graph, the charging cycle of the capacitor. It's increasing gradually, and all of a sudden, if we close the switch, yeah, we should provide a resistor. This is the discharging cycle of a capacitor. Okay, let me add a resistor in series with the capacitor so that it will not burst. Okay. It's charging to its maximum. Yes, you can see the LED, that is the lamp, glowing. So this is the discharging cycle of a capacitor. So that's all about the today's video about capacitors. So do support our channel Unbox Your Mind. So we'll be posting another video in the about inductors, and we'll slowly move into circuits. So thank you.